Awesome. Well, thanks everyone for coming in today. My talk's on the top 10 kind of being old school and that there's a kind of a new age of attacks out there. So this talk kind of came about when I'd have a lot of talks with developers and they go through their training for security and stuff, and it seems like a lot of what they get taught is, okay, here's OWASP top 10, here's SQL injection, here's cross-site scripting, here's the other big things. All right, we're out of time. Let's move on to back to coding. So there's a lot of big things out there that are pretty dangerous, and I think they're missed a lot of times when it comes to training and whatnot. So this is kind of trying to bring a little more exposure to that. So to give you a little more background on who I am, I'm Andrew Leeth. I go by the General on Twitter, but I'm a web apps security engineer at Salesforce. Various certifications and stuff, but I used to be a consultant doing AppSec work and network pen tests, and now I work for a cloud company doing it full time. So if you look at the Verizon data breach from this year, you'll see a lot when it comes to web app attacks, and there's certainly a lot of things here that we're doing wrong from an AppSec security standpoint. Stolen creds are number one, backdoors, SQLi, and you'll see a lot of things that end up being on the OWASP top 10, like SQLi, that's obviously injection, a lot of access control things and whatnot, but when you really look at that, I mean, the OWASP top 10 is just a fraction of the kind of vulns we're finding. Certainly we're doing a bad job at fixing those, but there's a whole lot of other things out there that we're doing that can really be dangerous to an organization or to an application. So just to refresh everyone on what the OWASP top 10 are, is you have things like injection. And when we say injection, I think every time you go to a developer or someone's had that kind of the training on the OWASP top 10, or you have a scanner, they're looking for LDAP injection, SQL injection, OS injection. They're not looking at anything else really than those. When you say injection to a developer, they're like SQL injection or things like that. If you talk about broken authentication, is usually pretty huge. Cross-site scripting, misconfigurations, cross-site request forgery, etc. These should be pretty well known. But some of the things that aren't on the list, XXE. So I mean, you can argue this is injection, but almost always I have developers that go through all the OWASP testing and they have no idea what XXE is. They have no idea that they need to secure their XML parsers or anything when it comes to that. So what XXE is XML external entity processing. So if you have a application that takes in XML data and is parsing that, there are certain things that can be dangerous if you're not protecting against it. So we have things like DTDs, where you can actually pull in local files, remote files. You could do things like port scan an internal network. You could DOS things. Lots of really bad things you could do with XXE. A really basic sample of that would be, say you have an XML file that's passed back and forth client side. If you drop in something like an entity here, this one would actually pull Etsy password. So that'd be really bad if I got that somehow on the client side from the server. I could do things like pull files in from a remote server that I host myself as the attacker on the internet. I could do things like call dev random and make the server take it offline. I do all sorts of really bad things, and sometimes it takes a little foo to make XXE work, but it's pretty simplistic, and the results are pretty bad. I mean, this is definitely a critical issue that you would see on any kind of pen test or review that you perform of an application. And a lot of times developers don't know about this. This is something you have to educate them on as you find it. It's definitely not mainstream. So I have a quick demo of that here, just using a vulnerable web app, and it's processing XML data, right? So I think the purpose of this action was to be able to inject other XML data, but this one actually works really well for XXE as well. So what they're really looking for here is this could just be straight up user input. that we paste into here, right? And it could be hello world, and then the client side that processes it into an XML payload, and we send it off to the server. Run into a lot of applications that do stuff like that. So without firing up burp or an interceptor, this is kind of what would be passed back. It goes through, it gets submitted, and then we see that down here is what would, maybe be displayed to the user as something from our payload. But if we take something malicious, like our example we showed a few minutes ago, you either intercept that with a proxy, or for demo purposes, we have that in a box here. As you see, we're pulling Etsy password, and from a web app standpoint, I've now got server, I'm pulling files off of a server. So that's definitely really bad. And you can definitely then use that to, branch out onto the internal production network that your application's running on. So something you really want to look for and take advantage of as a pen tester. But then as the blue team, you want to make sure you're protecting against that. Oftentimes, mitigations for this are not by default. I think .NET is now explicitly prohibiting DTDs, but that's the easiest thing. Is if you're not using DTDs, is just to turn them off. A lot of times there's a flag that you can flip that will just completely disable that functionality. But if for whatever reason you're using that functionality and you have to have DTDs, a whitelist approach, maybe some sort of regex where you're looking for only valid endpoints or valid data to be populated in those fields, and if not, then you drop it. But those are kind of the main crux of XXE. Another thing we run into a lot are things like server-side request forgery. And that sounds a lot like client-side request forgery, and it's kind of the same idea. So in client-side request forgery, we're really tricking the client's browser to do something that the user's not intending. So the classic example is I have a banking website and I load up an image that has a URL and the user already has a session and it performs a transaction, right? But for server-side request forgery, we're not attacking the individual users, which is really just kind of one at a time. We're attacking the server, which is really attacking the entire application. So there's a lot more risk there, right? So normally we'll have things like same origin policy that will restrict us for doing things like this, but you can do things to get around this. A lot of times what I'll run into is an application will have functionality where it says, hey, let me go grab this file for you. Let me link me to this JavaScript file you're hosting somewhere. I'll grab it for you and import it into our application, or something of that sort. So the server in that case, I give them a URL. The server is reaching out. It's grabbing down that file on the back end and then doing some magic with it, right? So that's really interesting from an attacker standpoint, because if not configured properly, I could do things like point that to internal addresses on the production network if they're not explicitly removing those. So I can all of a sudden start hitting 192 addresses on your internal network. I can start port scanning or seeing what responds on your internal network, maybe get into a configuration page for a switch, or just really use that as my foothold into your network. So that's definitely really bad. I can do things like grab a payload off of site I control, and if depending on how it's being parsed on the back end, I can have it do bad things on the server. See if any other slides. So yeah, like I said, it's really the server that's being attacked in this situation. We can look at the internal network. Payload could be malicious. Basically, what you really want to do here is go back to sanitizing, whitelisting, requests and response. If you're only expecting requests to be made out to the internet and not the internal network, then you should certainly be saying that the internal network is off limits and that you shouldn't be hitting bad things, right? We should be whitelisting only what we'd expect the user to bring forward.
Another interesting one.
Another interesting one that came about this year was race conditions. And I've had a couple different instances where I've run into cases around this, but I think the research that the folks that were testing the Starbucks app actually does a really good job of explaining it. So a race condition is typically always been thought of as a development bug, not really security related. So basically you can think of it as you have two threads, one starts first, the other one starts second, and one beats the other one done, and then that basically throws your application into a really poor state, right? So when it comes to security, what the guys found in the Starbucks mobile app was that if they were to have a gift card and they want to transfer the balance from that gift card, and they have two concurrent sessions of that open, and they're sending the request to transfer that balance at like the similar time, like right at the same time, then those two instances, if you tweak it just right and you get a little bit lucky, you're able to make one of those finish first. And then, so what happens when the second one finishes first is it's not deducting from your balance, and all of a sudden you're making up money that's not there. So it's really interesting. They had, I think they racked up like $16 on their gift card when it was a $15 gift card, and then they, gave the money back or whatever, as a proof of concept. But really interesting, but it's really hard to dive into finding these. So a lot of times what you're trying to do is stress test your application, throw a lot of requests at it, multiple of the same sessions. It's really difficult. Code reviews have been really good at finding things like this, but it's definitely something that, Starbucks would probably have poor detective controls on this, and you're basically making up money that you can use at their stores. So the risk is really high, but we really don't have a great grasp around how to fix things like this.
And then
another one that's pretty big too is we get developers like to build components and whatnot and share them, and then sometimes it's just maybe your free time and you're hacking something together and you share it on GitHub, and then all of a sudden an enterprise wants to say, hey, that's really awesome, I don't want to build it myself, let's just drop it into our code. So we do a really good job reviewing our code that we're putting out to that our developers are writing themselves. Then we slap on some JavaScript that this guy hacked up in his basement when he was learning Node.js, and all of a sudden now we got vulnerabilities in our application. So a big thing to do is really got to look at all the different libraries, JavaScript files, all different components and shared code that you're grabbing and dumping in your application. It's just as risky. You gotta look where that's stored. I've seen places where it'd be some guy's blog that we're referring to instead of pulling that down locally and hosting it ourselves. So if that guy's blog gets popped, then all of a sudden it's running JavaScript in your application. So there's some tools out there. A quick search was this cool little thing that you can add to your GitHub where it's looking to see the version on some things like Express or some very popular libraries, and it will tell you what version it is, if it's up to date, if it's insecure, if it's got vulnerabilities. I know the guys at Leeth Security, they have something with an API you can call for different libraries in Node.js to see if those components have known vulnerabilities with them. So you can easily make some API calls with the code you have to make a quick check on that. Something else that was kind of interesting this past summer was around SSL certificate issues. So a lot of times we're talking in the app world, and we're with developers and whatnot, but we really don't think of infrastructure and SSL. Like that's something that a sysadmin's dealing with or what have you. But there was some interesting stuff around AF networking for iOS, and basically it wasn't making any checks for things like domain name. It was just looking to see if it was a valid SSL certificate, and if it was, it would just pass the user on. So obviously really bad, because I could be the Gmail app and I pull a certificate from Microsoft, and everything looks hunky dory in the application to me. So as the user, so it was really kind of tricky also, because this kind of ties into the last one where this was just a library that's shared and used amongst many different people. So very, very difficult, but then it also kind of shows that we need to really expand our scope when we're testing our applications, and also think outside of just our strictly development box, as that's our role, and really look at securing the application as a whole. That was just kind of a quick overview. I only had 20 minutes, but any basic questions or anything else? Cool, awesome. Well, thanks for your time, and thanks for stopping by.